but to connect so we have audio. So what we're doing today is we're continuing on with solving our systems of equations with three variables, x, y, z. Now when we solve these here, we want to eliminate one of the variables first, either x, y, or z, whichever one is easier to do. Now if we look at this one here, x, y, and z, all of them actually are about the same. Because our 1x, well, we have two equations with 1x. We can turn them, they're already the same as each other. These two are already the same. And it'd be easy to turn either one of those into 5x to eliminate x. We can say the same thing for y, as well as z. It's going to be easy to turn them into each other. So, what do we want to eliminate first? X, y, or z? We can use y. Do we want to use the top equation, middle equation? Top or middle? One or two? For our eliminator. Top. So that's the equation we're going to use to eliminate y out of the other two equations. Now with the equation on the left, we don't have to do anything to get y by itself. It's kind of already there. Or not by itself, to get it to be the same. So we can go on and just put them over the top of each other and then see if we need to add or subtract. Negative y plus negative y. Negative 1 plus negative 1 is negative 2. So that's not 0. So we can't add the two together. We're going to have to subtract. Because negative y minus negative y, negative 1 minus negative 1. Well, the negative make a positive, and negative y plus y is indeed 0. So we're going to have to subtract all the way through. X minus x is indeed 0. Now negative z minus negative z is going to be negative 2z. Negative 3 minus negative 3. Well, this negative make a positive. Negative 3 plus 3 is 0. Now this is kind of nice. We've already gotten rid of one variable. We can solve it. And we got that z is equal to 0, yes? Well, let's continue this process with the other equation. Now, for y to eliminate out of the other equation, we need to multiply everything by 5. So we get 5y. Now, our 5 times x is 5x. 5 times negative y is negative 5y. 5 times z is plus 5z. This is going to be interesting. Questions on how we got to this point here? Now, since the signs are the same, we're going to have to subtract. Because negative 5 minus negative 5 is indeed 0. So those would cancel. 5x minus 5x will z minus 5z is going to be negative 4z. Negative 15 minus negative 15 is -4. 5 times negative 5 is negative 5. 5 times negative 5 is negative 4. 5 times negative 4 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 is negative We verified that z is indeed 0. Okay, that doesn't tell us much of anything because we still don't know what x and y are. Yes? Yeah, y is the funny one in this one that will do this. Not any of the homework problems. Those should not do this where you simplify one out and get the same number for both. So for our solution, we can say for sure z is 0. Okay. You don't have to rewrite this. I'm going to back up. I'm going to do this again. But this time, I'm going to cancel out z first. Because we know what z is. Z is 0, yes? And if we add these two together, x plus x is 2x. Negative y plus negative y is negative 2y. Negative z plus z is 0. Negative 3 plus negative 3 is negative 6, yes? Here. Since the z's are the same sign, z minus z is 0. Make sure. Yep. 5x minus x is 4x. Negative 5y minus negative y, well, the negative negatives make a positive, giving us negative 4y. Negative 15 minus negative 3, negative negative make a positive, giving us negative 12. Notice something interesting about these two equations. They look pretty similar, yes? Well, let's eliminate x next. This is already 4x minus 4y, yes? But this other equation, we're going to have to multiply it by 2, which will give us 2 times 2x is 4x. 2 times negative 2y is negative 4y. And 2 times negative 6 is 4x minus 4x is 0, yes? Negative 4y minus negative 4y is 0. Negative 12 minus negative 12. Is that a true statement? So there are infinitely many solutions. There are infinitely many solutions for this here. Now, I went back and solved and removed z to kind of show us this, but the other way we could have gone about this, kind of using what we knew, we know that z has to be 0. That's the solution. We found it, yes? If we look at the top two equations and plug z in for them, let me get... we would have x minus y plus 0 equals negative 3, which is telling us that x minus y is equal to negative 3. We can do the same thing with our second equation. And our last equation. And if you notice, all three of these equations are the exact same equation, yes? Because it's just x minus y equals negative 3. X minus y equals negative 3. 5x minus 5y equals negative 15. We've multiplied it by 5, yes? I'm going to take the top one. X minus y equals negative 3. I'm going to solve it for y. So we'll minus x. Minus negative y is equal to negative x minus 3. Divide everything by 1, negative 1. And we get y is equal to x plus 3. This is the equation of that line, yes? And what this means for us is that for any given x, there's a corresponding y value that has the value of x plus 3, which is here. So any value of x that we plug into x and x plus 3 for x and y, comma 0, will give us a solution point. So there's infinite number of solutions, yes? That satisfy this statement here. So no matter what value of x and x plus 3 we give, on this set we will have infinitely many solutions. For me, here, this homework, this is all I'm looking for. If you get 0 equals 0 at one point, do check the other side, especially we do eliminate the first variable out and you get 0 equals 0. Check the other side. Because it could be that one side, that first elimination gives us, we do the one here, and we get 0 equals 0. Okay, that's true. We do the other side, and we get 0 equals 7. That's not true. No solution. Just because you do get 1 0 equals 0 doesn't mean the other side's going to work too. Now, here, if we got z equals 0, still infinitely many, still works, both give us a true statement. But as soon as we get a false statement, we are done. Make sense? You ready to look at the next one? X, Y, or Z, which one's going to be easier to eliminate first? Because Z, we have 1Z, 1Z, 4Z, so we can easily turn them into the other. X, we have X, X, well, X, negative X, and 3X. We do have 2 X's we can easily turn into the other, yes? What do we have for Y? 2Y, 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 yes? Are they all the same already? So if I eliminate Y first, do you have to change anything about them? I'd pick Y since all three of the Y values are the same, yes? Doesn't matter which one we pick as the eliminator. I'm just going to pick the top one. Okay. Questions on how we've set this up so far? As we've been doing this so far, we've been subtracting, yes? We want the Y values to cancel, so 2Y minus negative 2Y. What would this give us? 0. 2 minus negative 2. 2 minus negative 2 is 4. So we can't actually subtract these two. We've got to add them because 2 plus negative 2, 2 minus 2 is indeed 0. So we're actually adding this one. Now we can add the other terms. 3x plus x is 4x. Negative z plus z So that would also be 0, yes? Equals 7 plus negative 11. 7 minus 11 is almost, yeah. If we were subtracting, yes. Because we switch it from subtraction to addition, because the middle term, y would not cancel out with it. So 4x equals negative 4. Mm-hmm. We have one variable yet left, yes? Is there any reason why we can't just solve it? No, I can just go what? Divide by 4, divide by 4. X is negative 1, yes? Now what we hope to have happen on the other equation, the equation on the other side, is that either A, everything cancels out but either y or z, or B, we have z, because we already have x, or x and z, because we want an equation with x or z, or just z, because if we get x again, that tells us nothing that we don't already know. So here, the signs are opposite, so we're going to have to add 2y plus negative 2y. 2 plus negative 2 is indeed 0. Negative x plus x. Well, that actually is 0 as well, yes? 4z plus z is 5z, yes? Negative 9 plus negative 11 is negative 20, yes? We agree? Hey, we just have one variable, solve for it. We would divide both sides by 5, telling us z is negative 4. This is kind of nice because everything canceled out already. Now we just got to find y. I'm just going to pick the top equation to solve for y. Now our negative 1 is just going to be negative 1. Plus negative 4 is negative 4. Negative 1 minus 4 is going to be negative 5. At this point here, we can add 5 to both sides, showing us negative 2y is equal to negative 6. Last but not least, we're going to divide both sides by negative 2, telling us y is 3. So negative 1, 3, negative 4 is our system, or our solution. Yep. Questions on this here? Questions on anything we've done so far? Mm-hmm. 5? Yes. So the reason we're multiplying something on both sides is we're trying to get that variable to go away. So for the problem before, when we multiplied by 5, because here, the eliminator equation, we started with just y, yes? But we want to eliminate y, and the y in that problem, let's see here, undo all this, that's fine. It's a little farther back because we did this one twice. Okay. It's not going to rewrite, but we can at least get here. So we want this y value to cancel out, yes? So for it to cancel, I need this other y value to be 5y. Signs really doesn't matter. But the number in front of this y is what? 1. So I need to change it to become 5. So to do that, we take this equation and multiply both sides by 5. Now 5 times x is 5x. 5 times negative y is negative 5y plus 5z. So now we have that 5y that we can add or subtract the two equations to get it to become 0. Does that make sense? Okay. You already did this one. So we're on to this one here. X, Y, or Z, which one do you want to eliminate first? Z. Okay, Z is kind of nice because we have two of the Z's that are already the same. Top equation or bottom equation? Which one do we want to be the eliminator? Doesn't matter which. The top. Yeah. So we'll write the other two out. 4x plus 4y minus 4z equals negative 2. 3x plus 2y plus z is equal to 0. Now the equation on the left or right the z's are already the same. They have different signs, but the numbers in front of them are both 1. They already match up there. So we can go on and simplify it. Now, since the signs are opposite, we're going to add. Because z plus negative z. Z minus z is indeed 0, yes? So that means we're going to add these two equations together. 3x plus x is 4x. 2y plus y is plus 30y. Z plus negative z is still 0. 0 plus negative 1 is negative 1. Now for our equation on the left, we need z to become 4z, yes? So that means we're going to have to multiply this first equation, everything in it, by 4. Now 4 times x is 4x. 4 times y is 4y. 4 times negative z is negative 4z. And negative 1 times 4 is negative 4. Would we add or subtract? Negative 4 plus negative 4. Well, that'd be negative 8, yes? So we can't add, we would have to subtract, because negative 4 minus negative 4, negative negative make a plus, giving us negative 4 plus 4, which is indeed 0. So we'll have to subtract all three. Now, 4x minus 4x is 4y minus 4y. So the entire left side is 0. Negative 2 minus negative 4. Negative negative makes a plus. Negative 2 minus negative 4. Because our negative negative 4 is going to become positive 4. Well, wait a minute, that's not a true statement. So this is no solution. We're done. We don't have to solve any further because we have that false statement. It's no solution. Questions on this here? Last one. Yes. Mm-hmm. Welcome. So we have one more problem we're going to do today. And then any remaining time you'll have to work on your assignments. So if we look at this last one here, X, Y, and Z, all of them are nice options for eliminating one out of the other two. I'm going to pick Y, and I'll pick the top one as our eliminator equation. And I'm picking Y because Y is the same in all three. So we have X minus Y plus Z equals 8. And we have 2X plus Y plus 2Z equals 16. Now, since the values of Y, the numbers in front of Y are the same already, we can go on and put them in there. Now, on the left, we have negative Y and Y. So if we add, what is negative Y plus Y? That would be 0. Negative 1 plus 1 is indeed 0. And since adding canceled those out, we're going to add across the whole thing. So X plus 2X, X plus X is 2X. Negative Y plus Y is indeed 0. Z plus Z is 2Z. And 8 plus 8 is 16. Questions on this so far? Let's look at the other one. Well, can we add Y and Y to get 0? No. This is one of the first ones where we're having to do two different operations for each of these equations. Because the first set, we could add them together to get the Y's to cancel out. Here, we're going to have to subtract. Now, 2X minus X is X. Y minus Y is 0. 2Z minus Z is going to be plus Z. 16 minus 8 is 8. Questions on how we got to this point here? So, what do we want to eliminate next, X or Z? Doesn't really matter which. We can do X. So what do I need to multiply this 1X by to get it to be the same as 2X? We multiply by 2. And if we distribute it through here, 2 times X is 2X. 2 times Z is 2Z. 8 times 2 is 16. And to get the x's to cancel out, we're going to subtract. 2x minus 2x is 0. 2z minus 2z is 0. 16 minus 16 is 0. Infinitely many solutions. There's infinitely many solutions for this here. And that's it. Questions on this here? Be ready for the homework. 3 through 5, 11, 13.